Welcome back to AI Insights, the podcast where we dive deep into the latest advancements in artificial intelligence. I'm your host, Alex, and today we're exploring a groundbreaking approach in the realm of Retrieval Augmented Generation, or RAG. Joining me are our esteemed experts, Dr. Emily Chen, Professor Raj Patel, Dr. Liam O'Connor, Dr. Sophia Martinez, and Dr. Mia Zhao. Welcome, everyone.
Thanks for having us, Alex. Excited to discuss this.
Glad to be here. Always a pleasure.
Happy to join the conversation. Let's get into it.
Hi, everyone. Looking forward to our discussion.
Hello, all. Ready to dive deep into CoRAG.
Fantastic. So today we're talking about a paper titled Chain-of-Retrieval Augmented Generation, or CoRAG for short. Dr. Chen, could you kick us off with a brief overview of what CoRAG is?
Absolutely. CoRAG is an innovative approach to enhancing RAG models by introducing a dynamic, multi-step retrieval process. Unlike traditional RAG methods that perform a single retrieval step before generating an answer, CoRAG retrieves and reasons over information in a step-by-step manner. This iterative process allows the model to handle more complex queries by continuously refining the information it gathers before producing the final response.
Right, and this is particularly useful for multi-hop question-answering tasks, where answering a question requires synthesizing information from multiple sources. CoRAG's ability to reformulate queries based on the evolving state makes it significantly more effective in these scenarios.
That sounds impressive. Dr. Patel, can you explain how CoRAG differs technically from conventional RAG models?
Sure thing. Traditional RAG models typically use a biencoder architecture to compress documents and queries into fixed-size vector representations, allowing for efficient retrieval using approximate nearest neighbor search algorithms. However, this approach can limit the model's ability to handle complex queries because it relies on a single retrieval step. CoRAG, on the other hand, employs a framework that dynamically generates a chain of retrieval steps. It uses rejection sampling to create intermediate retrieval chains, effectively augmenting the dataset with these step-by-step retrieval processes. During training, CoRAG fine-tunes a language model to predict the next action based on the current state, which includes the query and previously retrieved information. This multi-step retrieval allows the model to iteratively gather and reason over relevant data before generating the final answer.
Adding to that, CoRAG also introduces various decoding strategies at test time, such as greedy decoding, best-of-n sampling, and tree search. These strategies help control the compute resources by adjusting the length and number of retrieval chains, which is crucial for scaling the model's performance without exorbitant computational costs.
Interesting. Dr. Martinez, how does CoRAG handle the training process, especially with the intermediate retrieval chains?
Great question. CoRAG leverages rejection sampling to automatically generate these intermediate retrieval chains. Essentially, it starts with the original query and iteratively generates subqueries and subanswers using a language model. For each subquery, it retrieves the top K most relevant documents and prompts the language model to produce a subanswer. This process continues until it either reaches a maximum chain length or produces the correct final answer. Once these chains are generated, they augment the original QA datasets. The model is then fine-tuned on this enriched dataset, learning to predict not just the final answer, but also the intermediate steps. This multitask learning framework ensures that the model becomes proficient at both retrieving relevant information and reasoning through it step by step.
And what's really cool is that this method doesn't require manual annotation of the intermediate steps. It's all automated through rejection sampling, which saves a ton of time and resources in dataset preparation. Plus, it makes the model more robust by exposing it to a variety of retrieval paths during training.
Exactly, Liam. Plus, by fine-tuning the model on these augmented datasets, CoRAG can better understand the context and dependencies between different pieces of information, leading to more accurate and coherent answers.
That's a clever way to enhance the model's capabilities. Let's talk about real-world applications. Dr. Zhao, could you provide an example of how CoRAG might be applied in a business setting?
Certainly. Imagine a large enterprise with vast amounts of internal documentation, such as product manuals, support tickets, and knowledge base articles. A customer support chatbot powered by CoRAG could handle complex queries by iteratively retrieving and synthesizing information from multiple documents to provide accurate and comprehensive answers. For instance, if a customer asks, "How can I integrate your product with Salesforce?" and "What are the common issues users face during integration?" a CoRAG-enabled chatbot would first retrieve documents related to Salesforce integration, then delve into user feedback and support tickets to identify common issues. By chaining these retrieval steps, the chatbot can generate a detailed and nuanced response that addresses both the integration process and potential challenges, enhancing the customer experience. That's a perfect example. Additionally, in sectors like healthcare, CoRAG can assist in medical research by helping professionals find and synthesize information from various studies and clinical trials. This iterative retrieval process ensures that the generated insights are well supported by multiple sources, thereby increasing reliability and trustworthiness.
To add to that, financial services can leverage CoRAG for comprehensive risk assessments. By pulling data from financial reports, market analyses, and news articles, CoRAG can provide a holistic view of potential risks and opportunities, aiding in more informed decision-making.
Dr. Patel, the paper mentions that CoRAG achieves state-of-the-art performance on benchmarks like KILT. Can you elaborate on what that means?
Of course. The KILT benchmark is a comprehensive suite of tasks designed to evaluate knowledge-intensive language tasks, such as fact-checking, open-domain question answering, and entity linking. CoRAG's performance on KILT demonstrates its ability to generalize across a diverse range of tasks by effectively retrieving and reasoning over relevant information. In the experiments, CoRAG 8B outperformed many existing models, even those with larger parameter sizes. This indicates that the iterative retrieval and reasoning mechanism of CoRAG provides a significant advantage in generating accurate and contextually rich answers, making it a robust solution for real-world applications that require deep understanding and synthesis of information.
And what's impressive is that CoRAG doesn't just excel in academic benchmarks. Its real-world applicability is evident in how it can be integrated into various business processes, enhancing both efficiency and accuracy in information retrieval and decision-making.
That's impressive. Dr. Martinez, the paper also discusses test time scaling strategies. How do these strategies impact the model's performance and computational efficiency?
Test time scaling in CoRAG refers to the ability to adjust the model's computational resources based on the complexity of the query. For example, greedy decoding is a straightforward approach where the model performs a fixed number of retrieval steps. Best-of-n sampling involves generating multiple retrieval chains and selecting the best one based on certain criteria, which can improve accuracy but requires more computation. Tree search is another strategy that explores multiple retrieval paths simultaneously, providing a balance between depth and breadth in information retrieval. By adjusting parameters like the maximum retrieval chain length and the number of sampled chains, CoRAG can scale its performance according to the needs of the task and the available computational resources. This flexibility allows businesses to optimize for either speed or accuracy based on their specific requirements.
To add to that, the paper highlights that CoRAG exhibits a log-linear relationship between token consumption and performance improvement. This means that with controlled scaling, businesses can achieve significant performance gains without an exponential increase in computational costs, making it a scalable solution for various applications. And this scalability is crucial for businesses that need to balance performance with operational costs. Whether it's handling peak loads during high-demand periods or scaling down during quieter times, CoRAG provides the flexibility needed to maintain efficiency.
Speaking of scalability, can you share insights on how CoRAG manages to maintain efficiency despite the increased retrieval steps?
Sure. One of the key innovations in CoRAG is the use of rejection sampling to generate high-quality retrieval chains without manual annotation. This automated process ensures that the intermediate steps are relevant and contribute meaningfully to the final answer. Moreover, the model is fine-tuned using these augmented datasets, allowing it to learn efficient retrieval and reasoning patterns that minimize unnecessary computations. Additionally, the decoding strategies like best-of-n sampling and tree search are designed to optimize the trade-off between performance and compute. By intelligently selecting which retrieval chains to explore, CoRAG ensures that it doesn't waste resources on less promising paths, thereby maintaining overall efficiency.
Exactly. And the ability to dynamically adjust the retrieval process based on the query complexity means that for simpler queries, the model can use fewer steps, conserving computational resources, while reserving more intensive processing for complex multi-hop questions. This adaptive approach is crucial for maintaining scalability in real-world deployments where query complexity can vary widely.
Plus, integrating CoRAG with existing infrastructure can streamline workflows. For example, in a customer service setting, the chatbot can prioritize resource allocation based on the complexity of incoming queries, ensuring that simpler questions are answered swiftly, while more complex ones receive the detailed attention they require.
Let's touch on the challenges. Dr. Patel, what are some potential limitations or areas for future research in CoRAG?
One of the challenges mentioned in the paper is the increased token consumption associated with multi-step retrieval processes. While CoRAG introduces strategies to manage this, there's still room for optimization to further reduce computational overhead without compromising performance. Another area for future research is enhancing the model's ability to decide when to stop the retrieval chain autonomously. The paper discusses a variant where the model learns to predict when sufficient information has been gathered, but this is still in its early stages and could be refined to improve efficiency and accuracy.
Additionally, expanding CoRAG to handle more diverse and dynamic datasets beyond static corpora like Wikipedia could be beneficial. Incorporating real-time data sources and ensuring the model remains up-to-date with the latest information would enhance its applicability in rapidly evolving fields such as finance or technology.
And let's not forget about the integration challenges. Deploying CoRAG in existing systems requires careful consideration of data privacy, security, and compliance, especially in regulated industries like healthcare and finance. Future research could focus on making CoRAG more adaptable to these stringent requirements.
Another interesting direction is exploring how CoRAG can be combined with other AI techniques, such as reinforcement learning, to further enhance its decision-making capabilities during the retrieval process. This could lead to even more intelligent and autonomous systems.
Those are insightful points. Before we wrap up, Dr. Chen, could you share your thoughts on the broader implications of CoRAG for the future of AI and machine learning?
Certainly. CoRAG represents a significant step towards more intelligent and autonomous AI systems that can handle complex real-world queries with greater accuracy and reliability. By mimicking the human approach of iterative information gathering and reasoning, CoRAG enhances the trustworthiness of AI-generated content, which is crucial for applications in sensitive domains like healthcare, legal, and customer support.
Moreover, the framework lays the groundwork for developing more grounded and factual foundation models, reducing the prevalence of hallucinations and false claims that are often associated with large language models. This advancement not only improves user trust, but also broadens the scope of AI applications, enabling more sophisticated and reliable interactions between humans and machines.
Adding to Emily's point, CoRAG's ability to scale and adapt makes it a versatile tool across various industries. From automating complex research tasks to enhancing customer interactions, the potential applications are vast and impactful.
And as AI continues to evolve, approaches like CoRAG that emphasize reliability and factual accuracy will become increasingly important. They ensure that as our AI systems become more powerful, they also become more trustworthy and aligned with human needs and expectations.
Dr. Martinez, any final thoughts?
I agree with Emily and Liam. The iterative retrieval and reasoning capabilities of CoRAG open up new possibilities for AI applications that require deep understanding and synthesis of information. It's an exciting development that pushes the boundaries of what we can achieve with language models, and I'm eager to see how this framework evolves and integrates with other advancements in the field.
Absolutely. And from a research perspective, CoRAG provides a new avenue for exploring how models can better interact with external knowledge sources, making them not just passive repositories of information, but active agents in information retrieval and processing.
Thank you all for your valuable insights. It's clear that CoRAG is a promising advancement in the field of AI, offering both technical innovation and practical applications that can benefit various industries. For our listeners interested in exploring this further, the full paper is available at the provided link.
Thanks for having us, Alex. It was a great discussion.
My pleasure. Always happy to talk about these advancements.
Thanks, everyone. Looking forward to the next episode.
Great chatting with you all. Until next time.
Thanks, Alex. Catch you in the next one.
Absolutely. And to our listeners, thank you for tuning in to AI Insights. Stay curious and keep exploring the fascinating world of artificial intelligence. Until next time.